Alright, welcome back. In this video we're going to talk about inverse trig. And really what we're doing here is like, okay, we've kind of gone through and said if we know an angle, we can find side lengths. But what if we know side lengths, right? We know if these two legs are 3 and 4, then the hypotenuse has to be 5. So we've pretty much got this triangle all the way surrounded. How do we find the value of theta? That's what I'm going to tell you in this video. And there's not really a whole lot of point in me like telling you about what we're going to do. I'm just going to jump right in and show you how we're going to do it. So we're going to use inverse trig to find the measure of angle theta. Okay, we can start by finding sine of theta because we have an opposite and a hypotenuse. We can say sine theta in this case, which is opposite divided by hypotenuse, is going to be 2/5. We can say that's 0.4. Okay. But we should be able to find the measure of angle theta. At the very least, we could take like two sticks with length 2 and 5 and set them up and measure out the third side length and use a protractor to find the measure of the angle. So it's got to be out there somewhere. And the way this works is like, in the old times, somebody went and did it with protractor and looked it up, and they had trig tables. And so you'd go and you'd be like, okay, I need to find where is sine of theta equal to 0.4. And I'll show you what that looks like here in a couple minutes. But first I want to say, okay, find the measure of angle theta. What we got to do is we have to do the same thing to both sides of the equation. Okay, so let's give myself a little bit more room. If we start off with sine of theta equals 0.4, and we want to do the same thing to both sides, it's inverse sine is what it's called. Okay, also known as arc sine. Okay, but in this class we're just going to use the inverse sine notation. So we're going to do inverse sine to both sides of this equation. And you don't really know a whole lot about inverse sine, but really what it is, it's kind of like a lookup function. Like we're just going to go look it up in the table. I'll show you how to do it the once, and then you'll be able to do it in the future. So the arc sine or inverse sine of sine theta, they undo each other like exponentials and logs or squares and square roots. So inverse sine of sine theta is going to equal inverse sine of 0.4, and since these two things undo each other, we can just say, let's get rid of all that, theta is inverse sine of 0.4. Alright, so in the ancient times, or really not even that long ago, you go to a trig table, right? And you'd say, okay, I need to know where sine of theta equals 0.4. So I'm looking at this farthest column on the left underneath sine, and I'm looking to see where does it go to about 0.4. Okay, so that's between 23 and 24 degrees. So that's what I should be expecting to see. So I'm going to flip back to my, earlier work here and say, all right, I'm expecting between 23 and 24 degrees, but we're not going to be using a trig table here. That's not going to be our method of finding these things. We're just going to use a calculator. So we bring in the calculator, and then we just ask it to do inverse sine, which is second and sine. It's just a little up there. I'm not sure if you can see it clearly on your screen. We're going to ask for inverse sine of 0.4, or you could do 2 divided by 5, and we'd get right here this number that's between 23 and 24 degrees. Okay, because this is starting in on a new video here, I need to remind you that we need to be in degree mode here for the discussion we're having today. Okay, until we start talking about radians, we will always need to be in degree mode for this stuff. Okay, so I found that theta, which is inverse sine of 0.4, I'm really having trouble with this here, theta is equal to 23.578 degrees. All right, let's do one more. So we're going to find the measure of angle theta using inverse trig. So in this case, I've got the adjacent leg and the hypotenuse. So what I'm going to do, just like before, I'm going to start off saying what I know. All right, so I've got an adjacent and a hypotenuse, that's cosine. So I'm going to say cosine of theta is equal to 4 over 11. So if I want to access theta on its own, I need to take inverse cosine of both sides. And then that's going to leave me theta equals inverse cosine of 4 divided by 11, and that'll be something I can compute on the calculator. Inverse cosine, you can ask for a fraction bar, but I don't think this is a super risky fraction here, so we can just say 4 divided by 11 that way, and see that that's going to be 68.676 degrees. All right, now you try it on your own. So you're going to start by writing down a trig ratio based on what you know. You've got an opposite leg and an adjacent leg, and then you're going to use inverse trig to find the measure of the angle using a calculator. So go for it, work this with video paused, and then check your answer against mine, which will pop up in just 5 seconds. All right, there you have it. So I see that I've got opposite and adjacent, so that's going to be tangent. Tangent of theta is opposite divided by adjacent, 10 over 13. I take inverse tangent of both sides of that equation, and I see that theta is going to be inverse tangent of 10 over 13, and I run that through the calculator, and I get that theta equals 37.569 degrees. Put the little degree symbol there. That's not the most important in this class. All right, let's look at a new type of triangle. Let's look at an obtuse triangle and see what we can figure out here. What I'm proposing is that if we know, two sides and an angle, that I guess that's going to be enough for us to solve out the rest of the triangle. Okay, what we're going to need to do, though, is we're going to need to cut it up and, look at two separate triangles. So we kind of just come straight down there and cut down from angle B to side B at a right angle. And that's because it's not a certain type of triangle. It's not going to cut it necessarily in half. Okay, I'm going to call this this new side here H, and then I'm going to call this thing X and that thing Y. And I think I'm just kind of looking to find everything else that I can. So measure of angle A is 30 degrees. I'm going to put what they told me in black. Side C is 20. And side A is 14. All right, so I should be able to find X and H just using the 20 and the 30 degrees, right? Using forward trig like we did in the last lesson. Okay, and then maybe if I find H, then I'll be able to use inverse trig to find the measure of angle C, and then I can find everything else, hopefully without too much difficulty. Okay, so I'm going to start off by finding H. And, okay, to find H, that would be opposite side length and opposite leg and hypotenuse that I have. Or that I've got angle and hypotenuse, and I want to find opposite side length. That's so and SOHCAHTOA, I'm going to use sine. So I'm going to say sine of 30 degrees is equal to H divided by 20. And so I could solve for H by multiplying both sides by 20, so it'd be 20 sine of 30 degrees. I guess we could have also said this is going to be a 30, 60, 90 triangle, so H is going to be half the hypotenuse, which is going to be 10. But if you're not sure, you can run it through a calculator and see that 20 times the sine of 30 is going to be 10. Okay, then I guess the next thing would be find the measure of angle C. And so if we are looking at the triangle on the right, let's quickly draw you this. H we know is 10, this is 14, and we're looking for that angle. Okay, well the sine of C is going to be opposite over hypotenuse, is 10 over 14. So I'm just going to write that in here. Sine of C equals 10H divided by 14. And I might even go ahead and make that a 10 now that I know that. Okay, so sine of C equals 10 over 14. We can say that C is going to be inverse sine of 10 over 14. And we can run to the calculator for that, because that's not something we can do in our head. See that it's 45.585 degrees. Write that a little bit lower. And yeah, then I can just move on from there. Okay, I've got the measure of angle C. Okay, that means that I can find the measure of angle B now. And I think I found that, by finding each of the components that were adding up to B, but a more world-wise student in my class suggested that maybe I just add A and C and subtract them from 180, to get the measure of angle B. And I was like, that's definitely smarter. Okay, so we're going to find the measure of angle B. And we're going to say, all right, well, 30 plus C, so that's 45.585, plus B, that needs to equal 180. Okay. So I might subtract the 30 and the 45.585. But you know, when working with a calculator, can't be too careful. So, or working with the opportunity to have a calculator, you can't be too careful. Might as well just 45.585 minus another 30, and then I'd get 104.415, and that seems pretty reasonable as the obtuse angle. Alright, so if I go back up here and say, like, okay, what don't I have now? I have the measure of angle C, I have the measure of angle B, I need side length B. Okay, and I'm going to show you a technique in the next video that will really help with this, that will make this go a little bit faster. Okay, but for now, what we're going to do is we're going to find X and Y. Okay, that's going to be our method of finding B. So for D, it'll be find the side length B. Okay. I would start with the triangle on the left to find X. Okay, this is a 30, 60, 90 triangle. Okay, and the short leg is 10, so X is going to be 10 multiplied by the square root of 3. That'll save us a little bit of work. Let's deal with special right triangles. Sometimes it works out just fine. Y, we're going to have to be a little bit more careful. I would use the information I was given in the problem, which is that a equals 14, and if at all possible, I'd prefer not to use an inexact value like, I guess 10 is not an inexact value. Okay, there's not any way around. I could go up and use inverse sine of 10 over 14 if I wanted like a super perfect answer to a lot of decimals, but for us, we're always rounding off our answer to 3 decimals. This is going to be all right. Okay, y we're going to need to find by setting up a trig ratio. So I'm looking at the triangle on the right, and I've got 14 as the hypotenuse. C is what the angle I know, so I'm going to need to use cosine because I've got an adjacent leg and a hypotenuse. So I'm going to say cosine of C, cosine of 45.585 degrees is going to be equal to y divided by 14. Okay, so y is going to equal 14 times that cosine, and I'm just going to do that on the calculator. You don't need to watch me do that. 14 cosine of 45.585, and I get 9.798. Okay, and then, I guess I will show you what I'm doing here. Bring that up. Because what I'm going to do to find B, I'm going to say B equals X plus Y, and then I'm going to say, well, I'm going to add that to 10 root 3, square root 3, and I get 27.118. So that was a good example of us solving out an obtuse triangle. And it looks like that's all I got for you for this lesson. So as always, thanks for watching.